All right, everyone, let's take a look at this. So we have graphed our red line, which represents a linear function, right? We're going to label that f of x. And we have graphed our blue curve, right? That labels our, or rather that represents our exponential function, right? We're going to call that g of x for now. All right, so let's look at that linear function for a minute. Let's remember something important about a linear function or a linear relationship, right? It has a rate of change, right? It has a rate of change, and specifically the rate of change of a linear relationship, right? Rate of rage. Wow. There's a Freudian slip for you. Rate of change, right, is equal to the slope of the line that we use to graph the linear function, right? The rate of change is equal to the slope. In this case, the slope of this line f of x is equal to 2. So the rate of change of the function f of x equals 2x plus 4 is positive 2, right? But what about g of x? Well, g of x isn't changing by the same amount each time, right? Because that's what the rate of change of a linear function is, right? It's the amount by which the values of the function are changing. And if it's linear, that amount has to be the same each time over any fixed interval, right? But g of x is a exponential function, so it's a geometric relationship, right? So it doesn't change by the same amount each time, right? The values of g of x aren't going to change by the same amount over any given interval, right? So we can't really speak of an exponential function having a rate of change, but we can speak of its average rate of change. We can speak of its average rate of change over a certain interval, okay? We can speak of an average rate of change over a certain interval. And I think that'll be easy to understand once we get to work calculating something. Okay, so now that we know that g of x, or any exponential function, can have an average rate of change over a certain interval, well, what in the world does that mean? Okay, so over a certain interval means over a certain interval of the domain, all right? So for example, let's try to calculate the average rate of change, let's say from x equals 0 to x equals positive 3, okay? That's an interval. From 0 to positive 3 is an interval. And we can calculate the average rate of change of g of x over that interval. How do we do that? Well, we're simply going to find those 2 points, right? X equals 0, that point is right here. And the value of the function at x equals 3 is right here, right? And we're simply going to calculate the rise over run from x equals 0 to x equals 3, right? All right, so let me make some room. Try to make some room right here. Try to make some room, right? G of x, right, was, get my tool back, g of x was 2 times 1.5 to the x power, right? So we're going to have to find, we've done this before, 2 points, right? We're going to have to find 2 points. Let me just write here to remind us that we're going to calculate the rise over run, okay? We're going to have 2 points. 1 point is going to be 0, comma, g of 0, right? And the other point is going to be 3, comma, g of 3, right? And this first point is going to be our x1, comma, our x1, comma, y1 point. And this second point is going to be our x2, comma, y2 point, right? This is really a lot like what we've done for linear functions. We're just calculating the same thing for the exponential function, except just remember, this isn't the slope of an exponential function, because an exponential function doesn't have a slope. It is the just the average rate of change over an interval or between any 2 points. We could think of it as the slope of a line that would connect those 2 points, right? We can think of it that way, but it's not the slope of the exponential function. All right, so let's try to calculate those 2 points here, okay? All right, there's not a lot of room to work with, is there? So I'm going to have to write on this graph. All right, so let's try to calculate g of 0, right? Because we need to know the value of the function g at x equals 0, right? Well, that's going to be 2 times 1.5 to the 0 power, right? That's going to be 2 times 1, which is going to be 2, right? So we're going to be able to have our first point here. Let me replace this x1 and y1 with the actual values, right? Our first point on the plane is 0, 2, right? I mean, really, we could have just looked at it and found that out, but I want us to have some decent experience calculating, okay? Now, let's try to calculate the value g of 3, right? Because we want to find out how much g changes, or the average rate of change of g from 0 to 3, from x equals 0 to x equals 3, okay? So we're going to plug this into our function here, right? It's going to be 2 times 1.5 to the third power, okay? Let's try to figure out what that would be. 2 times 1.5 to the third power, that's going to be 6.75, okay? So at x equals 3, the value g is equal to 6.75, okay? So we have our second point. We have our second point, which is 3, which is 3, comma 6.75, okay? All right, so now we got our 2 points. So let me make some room so that we can calculate the rise over run. All right, bear with me as I try to, darn it, as I try to get some room here. There we go. All right, so let's try to get rid of this. We know that we have our, darn it, our x1, y1 point, which is 0, 2, and our x2, y2 point is 3, 6.75, right? Okay, so y2 minus y1 over x2 minus x1, right? This is rise over run, is equal to what? It's equal to 6.75 minus 2, right? Divided by 3 minus 0, right? What's 6.75 minus 2? That's 4.75. And what's 3 minus 0? That's 3, right? So what's the average rate of change? It is, let's round it to 1.58, okay? So we can say that, and let me create some more room to make this statement. We can say that the average rate of change, you can say the average rate of change of g of x from x equals 0 to x equals 3 is positive 1.58, okay? All we did was we decided over what interval we wanted to measure the average rate of change. We took the value of g at the beginning of the interval and the value of g at the end of the interval, right? Found our 2 data points, our 2 points on the graph at the beginning of the interval and at the end of the interval, and we calculated the rise over run, the change in the y value divided by the change in the x value from our first point to our second point, and that gives us the rate of change of the exponential function over that interval. Okay, let's look at this problem. Find the average rate of change of h of x equals 1/2 times 4 to the x power from x equals 2 to x equals 4. All right, this is an exponential function we have here, h of x. the initial value of this exponential function is 1/2, and its common ratio is 4, okay? And we want to find the average rate of change of h of x from x equals 2 to x equals 4, okay? So we need 2 points. We need the point of the graph h of x at x equals 2, and we need the point of the graph h of x at x equals 4, okay? So we want to be able to find x1 comma y1, right, equals 2 comma h of 2, right, the value of the function at x equals 2. And we want to find x2 comma y2, right, which equals 4 comma h of 4, right? We want to find the value of the function h at x equals 4. Okay, because then once we have those two points, we can calculate the change in y over change in x, right? Which is, let me just write it for now, which is of course y2 minus y1 over x2 minus x1, right? And that's the average rate of change of the function h over this interval. All right, so we want to find h of 2, right? Let's find h of 2 first so that we can get our first point, right? Let's find h of 2. h of 2 is going to be 1/2 times 4 to the second power, right? And that's going to be 1/2 times 16, which is going to be positive 8, right? It's going to be positive 8. So why don't we go ahead and already substitute this h of 2 with what the value of h of 2 is, right? The value is positive, the value is, there we go, positive 8, right? Great. So now let's find h of 4, right? Then we'll be able to get our second point, right? So that's going to equal 1/2 times 4 to the 4th power, right? Well, what's that going to equal? That's going to equal 1/2 times 256, right? Which is going to equal 128. It's going to equal positive 128, right? All right, so now we can erase h of 4 because we know what the value of h of 4 is now, right? It's 128. Excellent. So we have our first data point and we have our second data point. And of course, we can use those to calculate the average rate of change of h of x from x equals 2 to x equals 4, right? Okay, so let's substitute in these values. y2 minus y1, that's going to be 128 minus 8, right? Divided by x2 minus x1, that's going to be 4 minus 2, right? Well, this is going to equal 120 divided by 2, right? Which is what? Positive 60, right? And there's our answer. The average rate of change of h of x equals 1/2 times 4 to the x power over the interval x equals 2 to x equals 4 is positive 60.